polynomial functions and their graph. Basically says, okay, everything in 2.1 was just, the complex numbers. 2.2, all quadratics. Everything was quadratic, quadratic, quadratic. And then they say, all right, well, 2.3, we're going to go beyond quadratics and talk about it. But we're going to, basically, here's what it is that with polynomial functions, this is anything that's, polynomial just means it's more than whatever we're doing. So basically, here's what it is that if your highest power for the degree is basically your highest power. So when they start talking about some different polynomial functions on this one, they're going to give you some different quadratics and ask you about everything that's here. And here's where they kind of dig into the details of it a little bit more. When they talk about functions, this is where we're going to kind of limit some of the different graphs that we talked about back in chapter 1. That for functions on these things is that you're going to have it so that there are no variables in the denominator. There's no skip values of x. And the graphs have to be smooth. Okay, so when I talk about the polynomial functions on this one, I guess is really where we're talking about it here. And this is where they dig into a little bit more detail than what we did back in chapter 1. Chapter 1, we basically said if we didn't have y squared, we were good to go. This one, they said, all right, well, now that was just kind of more of just functions. If we talk about polynomial functions, this is more of the stuff we're actually going to do. No variables in the denominator, because if you have a variable in the denominator, you cannot use a x value at that point because it makes it undefined. So that one kind of kicks that one out. You cannot skip any values, which means when we did square root's out because you skipped the whole back half of the graph. You had a certain starting point, and then you skipped everything beyond that one. So for the skip values, that means that there's no square roots. So when I look at these, it's not square roots. The graphs have to be smooth. That gets rid of the absolute value because it's not a smooth graph. It comes straight down and straight back out. So absolute values are out. Square roots are out. And for these, when we talk about polynomial function for this one, that the variables that your degree is going to be a whole number. So put a comma there, and your degree is a whole number. So your highest power, or let's just go ahead and say all the exponents, have to be a whole number. Well, I say the positive integers, because technically we'll stay away from 0. Okay, so some of the very basic things they're going to ask you right off the bat is they're going to ask you just some basic questions of yes or no is the equation a function. Okay, if they give you an equation, this is where basically, again, no absolute values, no square roots. You can't have anything in the denominator variable-wise. And you cannot have exponents where they're fractions or anything other than whole numbers. This one, it fits all those things, so they say, is this thing a function? Yeah, we're good to go. (7x to the third plus 15x minus 1 over x). No, right? Because you've got this fraction part that's here. So is it a function or not? No, not a function. And so they're just going to give you a couple of basic problems in the beginning just to say, okay, here's this equation. Is this thing a function or is it not a function? So again, this is where they kind of step it up a little bit and say, okay, polynomial functions, because now that makes it more complicated than just saying it's a function. So they just give you a couple other options on these things to kind of figure out exactly what you're doing. They may give you a couple of graphs also. And ask you, okay, could that represent a polynomial function? Well, again, it's got to be smooth. So for one like that, that's a no. You know, if it was a smooth graph, it would have to be something kind of like this. That one's okay. Okay, so that's just them kind of digging back through the basics and saying, okay, now we're not worried about square roots, we're not worried about third roots, we're not worried about absolute value. Basically, that leaves you with x to the first power, x to the second power, x to the third, x to the fourth, x to the fifth. They all have to be x to some power where it's all whole numbers, there's no fractions and decimals and all these other things that's here. And here's basically what it comes down to. Since we're doing everything x to the first, x to the second, x to the third, you can basically break it down into one of two different types of categories here. Based on if your degree is even or if your degree is odd. So we're going to look at kind of the even part here. If the degree is even, and the coefficient with the term is positive, your graph is going to be, so basically we're looking at two things here. And again, it always comes down to if it's even or odd, because basically you've got two different options in this thing. But if the degree, if your highest powered term is even, it's going to be similar to x squared. So that's always going to be the one thing that you're going to do. Doesn't matter about anything else. If the highest power term is even, it's going to be something similar to x squared. So if the coefficient is positive, they're going to ask you, okay, what about the ends of the graph on this thing? Here's what it comes down to. If it's positive, it's just like it was the positive number with x squared, that both ends are going to be up. Oh, hang on. So if the graph is similar to x squared, that both ends of the graph are up. Okay, so if it's even and it's positive, then both ends are going to be up. Now, the thing that they don't really dig into on this part, that we'll, maybe if we've got time we'll get to it in 2.4, but that may be for another day. What happens in the middle is what we'll dig into in the sections that's coming up in 4, 5, and 6 and the rest of the way. And mostly that we're looking at for this part of it, that we're going to dig into in the first little bit of this one, is that right now we're looking at just the endpoints. So if the degree is even, it's always going to look something similar to x squared. So it's going to look something like this. Now, depending on the power, it may come in the middle and kind of do a couple extra loops. May have a couple extra hops on the inside. But it's going to be something similar. The basic shape of it is still going to look something like x squared. Okay? If the coefficient is positive, is negative, then we'll say that both ends of the graph are down. Okay, so you can put a great big box around that one because that's one. Yeah, degree is still even. We'll put a big box around that one. So that's the big catch on this one. If the degree is even, then this is everything in this box. So it's one of two options. If your highest powered term, which is the degree, if that's even, it's going to be similar to x squared. It's either both of them are up or both of them are down on the ends of it. Now we'll come back and dig into the middle of it later, but that's more the x-intercepts and the y-intercept stuff with the factoring, all the other stuff that we did. But that'll come a little bit later. So this is just kind of the degrees even. Both ends are up, both ends are down. Okay. The other part is if the degree is odd, well, we've got a different set of things to worry about. Okay, so if the degree is odd and the coefficient is positive, coefficient is positive. Oh, I got to put this back up here. So if the degree is odd, this is going to be similar to y equals mx plus b. So if it's even, it's like x squared. If it's odd, which is basically, if you did y equals mx plus b, this was x to the first power. So everything we do on this one is going to come back and be similar to this one. It's going to look kind of like slope on this thing. Now, technically, and that's what you want to kind of get at it, but here's what technically what they say. It's really, they're going to say it's similar to y equals x cubed. So, I mean, technically you can think about it that way. Now, we're still going to borrow a little bit from slope of it because it's still got that kind of S-shaped graph to it, but we're going to kind of think about slope when you go through this one. So if the coefficient is positive, this is where you want to think about a positive slope. Try that again. So the graph is similar to x to the third, but really it's almost more similar to, it's kind of a mix of x to the third and just a y equals mx plus b. If it's a positive slope line, just think about what a positive slope line looks like. Just like this, right? So that the left side is down and the right side is up. So if the coefficient is positive, the left end is down and the right end is up. Now, again, it's going to look more like x to the third. In the ends of it, we know it's going to do that. In the middle, again, it's one of those things we don't know exactly what it's going to do in the middle because it may have some extra humps in it, it may do some of this. But overall, the ends of the graph are going to look something like x to the third or even like just a positive slope line. Okay, and then the other option is if the coefficient is negative, well, it's going to think, and again, you're thinking of a negative slope line. It's going to be something like that, where the left end is up and the right end is down. Okay, so there's your two different cases. If your highest power term is even, you've got one set of rules. If the high power term is odd, you got a different set of rules. And what they're going to ask you to do in the first few questions when they get to this one, they're not even going to worry about anything else. They're just going to say, okay, here's an equation. And they're going to ask you to use the end behavior. Here's a question. They're going to say use the leading coefficient test. To determine the end behavior. Okay, so all that thing about the highest power term and the coefficients, that is the leading coefficient test. You figure out what the highest power term is, the coefficient, positive or negative, tells you what it's going to do. And so here we go. Okay, so let's say we're going to do 3x to the 4th plus 6x squared minus 10. And your answer, when you go through these, you only need one of two words, up or down. That's all they're going to ask for. They're going to say, all right, just tell me up and down. What's this thing going to do? So as you're going through this one, the only thing you have to worry about is here's your highest powered term, and you need the number that goes with it. First thing is you have to look at the exponent. That's even. So that means it's got to be similar to x squared. So if this thing is even, it's either both up or both down. And the number in front, that's positive, right? So first thing is you got to get the power. It's even. It's positive. So if it's even, that's similar to x squared. And if it's positive, that means they're both up. So this one's going to be up and up. Now, you always give me the left. Put the left number on the left, put the right number on the right. So the left side is the first one. You're going to tell me what the left hand's doing. The second one, you're going to tell me what the right one's doing. So for the answer, you just tell me it's up and up. I know that's not a plug for Target and their brands. Okay, let's go negative 4x to the 7th plus 3x minus 10. Okay, there's your highest power term, x to the 7th. Again, you got to take that exponent and the number goes with it. And the first thing that you have to realize is that's an odd exponent. And that tells you the shape. If it's odd, it's going to be similar to the odd graph, which was either x to the 3rd or y equals mx plus b, so you're going to have one up and one down. The number in front tells you which one's up or which one's down. In this case, it's negative. So when it's negative, think about a line that's got a negative slope. It's not really negative slope, but think about, if it was a negative slope line. That's that, right? So your left is up and your right is down, so this one's going to be up, comma down. And when they're asking about just talking about the end behavior, that's all you're worried about. You're not worried about what's in the middle. Just we're saying, all right, if you stretch this thing out to infinity, what's the graph going to look like? Because it's either pointing up or it's pointing down. One of those two things. All right, let's give you one more. But they'll try to get as tricky as they can on these. They'll take your highest power term and not have it be first where it's second or third or somewhere else at the end. But again, you're still just going back and you're really not worried about anything else other than that highest power term. So again, that's x to the 4th, and you've got to take the number with it there. Okay, so that's an even exponent. And based on the exponent, that's either they're both up or they're both down. Or if it's even, they're both up or they're both down. And then from there, that's going to depend on the sign of it. In case it's negative. So if it's x to the fourth, it's similar to x squared. If it's negative, that means they're both going to be down, so it's going to be down and down. Okay, so that's the first thing they look at in 2.3 is just what makes a polynomial function, and then, okay, here's the basics of what's happening on the ends of the graph and how this thing's going to do. Now, the one thing I did notice in this one, I'm going back because I'm used to what we do at the department on this one. I think this one, instead of saying up and down, I think they say falls and rises. So where you have this one, this would be a fall and a fall, or falls and falls, I think. This would be a rise, or rises and falls. So they, instead of saying up and down, they may say rises and falls. Same thing. You know, one or the other, I don't really care. It's just depending on how they're going to ask you to fill that gap in there when they go through this. Yeah, up, down, falls, right. I don't, you know, up, you know, positive, negative. Just as long as you give me falls or rises, up or down, I don't really care. Just tell me what it's doing, and I'm good. And, you know, to me, that's an easy multiple choice question. You know, give me the options on that one. Okay. After they've gone through and kind of gone through this, here's where we're going to figure out what's happening in the middle of it. If you want to call it the middle of the graph, I don't know if you really, yeah. So the middle of the graph is what they're going to determine by the zeros. And again, the zeros is basically the same thing as the solutions or the x-intercepts. So when they talk about the zeros, that's the same thing as the solutions. That's the same thing as x-intercepts. So the middle of the graph is determined by the zeros. That once you've got those pieces of it, then that's going to kind of tell you what's happening with it. Now, here's the thing that they kind of do with this one to kind of tie in all the other parts that go along with this one. Depending on if you can get these in factored form, this is where it all kind of goes through this one. Best way of saying this. That as you're going through the solutions on these, here's one thing that we're kind of tying with it. And this is where we'll start to kind of tie in everything that goes along with the solutions on these. But the multiplicity of the zeros is basically this. The multiplicity of zeros is the exponent that's on each parentheses of the equation when it is written in factored form. So the good thing about section 3 is that by them talking about the multiplicity and everything being in factored form, that means everything that they give to you will be factorable. So you don't have to worry. Now, you can't use a quadratic formula on most of these because once you get to x to the third, x to the fourth, x to the fifth, you cannot use a quadratic formula because it only works for x squared. So that's kind of the good thing about this section is that most everything you're going to do now, you're going to have things that's going to factor. And basically, here's what it is. If the exponent is even when you're going through these, then the graph, when you're going through and graphing these things and figuring everything out that's here, the graph is actually going to turn around at that 0 or at that solution. And this is kind of going back, if you think about the x squared, going back to that one, that if you have, x squared would be an even solution, right? That you've got x to the second power. That when we had that graph, if we were just doing the very basic powers of x squared, this is one that when we did that graph, it would come in here, it would hit at 0, 0, it would turn and go back up. Well, that's what they're trying to say for this one, is that anytime you have something that's going to be factored, now when we're doing these, it's going to be more like x minus 1 squared. We'll give you one of those problems here in a second. That means when you get that solution, it's always going to have that curve where it's going to be a parabola type thing at that point, where you're going to come in, hit the x-axis, and you're going to turn and go up. Or if you're underneath it, you're coming up from the bottom, you're going to hit it, and you're going to turn and go back down. If it's even. If it's odd, the graph is what they're going to say crosses through the x-intercept or through the x-axis. Similar to that, what if it was x to the first power, x to the third power, where it's like slope again. It's going to hit the line and it's going to just keep on going as it goes through that part of it. Okay, now they're going to give you a couple of things on this. The very first thing that they're going to ask you to do is they're not even going to ask you to graph on these. They're just going to say, all right, here's an equation that we have. Tell me what the zeros are, and tell me if it crosses the x-axis or if it goes on through it. So we're going to find the zeros and state the multiplicity. And tell if each solution turns around or crosses through. Okay, so let's say you have something like this. And again, this one's already in factored form. We'll do some here in a minute where they're not in factored form. And those will do more of a review of some special cases of factoring more than it is. It's still doing this part, but it's really more some factoring review. Okay, so if everything is factored, this is where, again, you take each parentheses one piece at a time. You can almost kind of draw a line and separate everything through here. That for this one, you've got these. Now, the 4 doesn't have anything because there's not an x with it, so you don't have to worry about this one. But for this part, you have x minus 3. So for this one, exponent is 2. So that's your multiplicity. Again, key thing though is that it's 2, but the key thing is that's even. For this one, there's basically not a power there, but again, that's like an understood 1, so your multiplicity would be odd. Okay, so when they talk about the multiplicity, it's really not, it is the number, but honestly, it's more of it's even or odd, because that's going to tell you what it's going to do. So again, if this thing is even, this means this graph, when you get it, is going to turn around. This one, because it's odd, that means it's going to cross through. And if it's factored, the solving is the easiest part of it, because for this one, it's just x minus 3 equals 0, so that one's x equals 3. So there's that solution. This one is at x plus 7 equals 0, so this would be x equals negative 7. Okay, now this one, in the directions, they don't ask, that's all they ask you to do. Just tell me the multiplicity, tell me if it turns around with each solution that you go through this way. Let's go ahead and graph this one just so you can kind of see what's going on with it, because the next couple of questions, we may not do that, but for this one, let's go ahead and kind of give you a graph up here. Okay, so your x-intercepts, that's your solutions. That's where you're going to put those numbers on the x-axis. Maybe one at x equals 3 and one at x equals negative 7. Okay, now here, if there's any one bad thing about these, it's already in factored form and you have to graph these. This one was x minus 3 squared, right? So there's x times x, this part would be x squared. This one's x to the first. So if it's in factored form, you basically have to go back and add all your powers back together that's on each parentheses. So if you look at this one, it would be x to the third if you combine everything back together. And you've got your number that's in front, so this thing really is 4x to the third. That would be your leading coefficient, or your leading term. Now, here's where you're going to do what we just did with end behavior. If it's 4x to the third, it's an odd power. That means that it's going to be like a positive slope line because the 4 is positive. So the left end is going to be down, and the right end is going to be up. Okay, now, here's what that means when you get ready to start graphing this one. When I talk about the left and the right end, basically that's saying, all right, find the leftmost zero or solution that you have. And from here, you have to draw a line that goes down. The right is going up, so find the rightmost solution you have, and from here, you have to draw a line up. So there's your ends of your, just like it did on the previous question. If it was x to the third, because again, this one's x squared, and this one's x to the first, so altogether there's 3 x's. If you put all that together, the right side has to go up, the left side goes down. And somebody says, well, what about if there was one more solution in the middle? Right now, we're not worried about it. We're just worried about what's happening with the right end of the right zero, and it's like the left zero and the right zero. Left zero, everything going down. Right zero, everything has to go up. So that's where that ties in. Everything else in the middle ties in with this whole turning around and crossing through. That at x equals 3, says it turns around, right? Which means it's not going to cross through. That means that graph is going to come in here, it's going to get close to the bottom, and it's going to turn around and head back up in this direction. And once you're up here, it says at negative 7 it crosses through, so that means this graph has to cross through and do something like that. And that's what it's saying about the turning around and cross through. This one has to turn around and bounce off and then come back up. Now, for what we're going to do, that's going to be our basic graph of that one. This is screaming for a multiple choice question. Because if you find all the other points in between, you're supposed to do the intermediate value theorem, where you plug in numbers and you'd find out exactly where this thing would top out at. We don't have time to do all that. So in the homework, it shouldn't ask you to do anything about the intermediate value theorem, because that's where you hone in and you find out exactly where this thing would top out, or if it was down here at the bottom, you find out exactly where it bottoms out. But for what we're going to do, that's all you need is just the basic shape of what it's going to do to kind of figure out the numbers there. So that's where all that kind of ties together with all those. Now, we'll come back and do some more of those, but that's the basic shape of what you're going to do. So the multiplicity part, first time I taught the class and been doing this way back when, I kind of blew the multiplicity off. It's like, whatever. And then after I did it the first time, I went back and looked at it, and I was like, oh, that's a big deal. That tells you a lot about the graphs and what this thing is doing. So if you can get the multiplicity, that tells you the big things about what's happening at those points to tell you exactly what the graph is going to do as you're going through those. So that's one of those multiple choice questions where I could give you the 3 and the negative 7, and just have the graph drawn 4 different ways, and you just got to know about the multiplicities just to come back and make sure it does the certain things at the right point of what it's doing there. Because you could have the graph going this way, coming down here, and then crossing through and doing this, or you could have doing this one coming here and doing this, and then shooting back up. There's all kinds of ways that you can take those graphs and tweak them and change them just a little bit to where everything's off by just a fraction of a number if you're going through those. Yeah, now I'll highlight the zeros, highlight those solutions. Here's the multiple choice, and just tell me, all right, which one of these is the right graph based on, based on this equation, which graph matches this thing out. Just to make it quick as we're going through this one. All right, let me give you a couple more of those. And this one, we're not going to graph these. This is more of, really, it's more of a practice of factoring on these. So we're going to kind of go back, just find the zeros and the solutions and whether they turn around or not. Let's go x to the third minus 2x squared plus x. Okay, now, if they give you one that's not in factored form, you have to factor it, because everything we're doing right now is based on this one. If you go through this one, again, you can kind of forget about the f of x for a minute, just look at it this part of it. You've got to try to factor this thing. Well, they all have x's, so let's take the x out first. So take 1x out of each one of those, and again, put that 1 in there as a placeholder. Make sure you got that one still sitting in there. Now you've actually got something you can factor on the inside, because you're looking for the factors of 1 that would get you negative 2. Well, the only way you can factor 1 is it's going to have to be 1 times 1. In this case, they both need to be negative. And if they're both negative, you've got the same thing twice. Then you can rewrite that part as x times x minus 1 squared. Okay, so there it is in factored form. That's what you wanted. And from here, this is where you're going to kind of break it up into the two parts. Draw a line right down through the middle of it here if you need to. That for this one, power is 1, so that's your multiplicity. So your power, which is really the same thing as multiplicity. And again, it's not really, it's important that it's the number, again, the important thing is it's odd or even. This one, your power is 2, which means your multiplicity is 2. But again, the key thing is that's even. And again, the even and odd powers tells you what it's going to do. If it's odd, that means you're crossing through. And if it's even, that means you're going to turn around. Okay, now, as far as getting the solutions, this one you're going to take x, set it equal to 0. That one's done. This one you're going to take x minus 1, set it equal to 0. So to solve that one, you're just going to add 1 to both sides. So that's x equals 1. Okay, so again, whenever you're plotting the points on this one, we're not going to just to save us a little bit of time. This one, you'd have x equals 0. This graph is going to cross through 0. So you got a line that would look something like this, if that's your x-intercept. This one, when you get to 1, you're going to come down and hit it and turn and go back this way. Unless you're coming at it from the bottom, then you're going to come up and turn and hit it and come back down. So this one's going to be a line looking like this. This one is going to be a line that looks either like this or like this, depending on what the end behavior is going to be. And that's where you're going to have to kind of tie in the end behavior to know exactly which way that part of the graph is going to go there. Now, if you want to scroll back up real quick, the good thing about written it this way is that your leading term was x to the third. So based on the end behavior, it's positive, so that means the right end is going to be going up and the left end is going to be going down. So you know that at the end you have a graph that would look something like that. We just got to go back and figure out what's happening in the middle of it there. But according to this one, 0 is on the left, so that one crosses through. The one on the right turns, so once you get here, you only have one option to make it turning back, something like that. Yeah, so x to the third, it looks something like that in the middle. That's where the multiplicity comes back and tells you exactly, what we're going to do there. All right, let me give you one more. And again, this is more factoring than it is anything else. Okay, let's go x to the third plus 7x squared minus 4x minus 28. You have to factor. Now, it's 4 terms. I don't think we talked about this. Do you remember what to do if you have 4 terms to factor? So I don't think we talked about it last time. I think we stopped at trinomials. If it's 4 terms, you have to do factor by grouping. And for factor by grouping, basically you take the first 2 terms together, you take the last 2 terms together, and I always put a plus sign in the middle just to keep everything separated out. So you're going to put x to the third and 7x squared in one parentheses, and then plus, take the last 2 terms, signs and all, and those will go in the last set of parentheses. And from there, you're going to do basically greatest common factor of the first parentheses, and you do greatest common factor of the second parentheses. So x to the third, x to the second, you can take out the greatest common factor of x squared. That'll leave you with 1x here. Take the x squared out, and that'll leave you with a 7 there. Okay, do the same thing with the second parentheses. Take out the greatest common factor. Now, in this case, they're both negative, so take out a negative. 4 and 28, you can divide them both by negative 4. Take that out, that leaves you with the x here. Negative 28 divided by negative 4 makes that a positive 7. Now, here's the good thing about greatest common factoring. It's got a self-check built into it. When you do factor by grouping. When you do factor by grouping, what's in parentheses here in your blue part? These two, that's not the wrong thing. Oh, highlighter, here we go. These 2 things in the parentheses have to be the same. If they're not the same, you didn't do factor by grouping right. So it's got a built-in check. Once you do that first part of it, you take out the greatest common factor. If it's not the same, you did something wrong. I mean, it's just that simple. Either that or it's not able to be done by factor by grouping. But right now, everything has to be done by factoring because that's what we key on. Okay, so once you've done that part, you've got the x plus 7 that's in parentheses. Go ahead and drop that down. Whatever these 2 greatest common factor terms were, they go together in parentheses by themselves. And depending on the problem, that would be it. Now, for this one, you can go one more step, because if you have x squared minus 4, that's the difference of 2 perfect square numbers. So for that one, you could go one more step and break that one out as x plus 2 and x minus 2. And then you can bring down the x plus 7. Okay, now we're right up to time here, so let's get this one finished up real quick. All right, multiplicity. Every single one of these has a power of 1 because they don't have any powers, so they're all understood to be multiplicity of 1. Which means they're all going to cross through. And so if you solve these, you get x equals negative 2 on the first one. This one you would get x equals positive 2. And that one you would get x equals negative 7.